one's about the log equations that you need me to answer before we start the exponential ones. Now, like I said, tomorrow we'll be doing a combination of these two types, what we're doing today, and the log ones, and you'll put it all together, and it'll be just classwork tomorrow with a homework assignment. You'll probably have time to do both of them tomorrow. So it'll be more practice for that. Okay, then let's talk about exponentials. You have already solved one type of exponential equation. Do you remember what it was? Or what we did to solve it? In other words, if you look like at number 1 and 2, 5, you changed them to force them to have the same base, right? We said, well, wait, 25 is the same thing as 5 to the second power, and once the bases are the same, I can go, oh, you know what? That means that the exponents must also equal each other, and then you solve from there. Remember that? Good, thank you. So this one, now number 2 is a little bit harder. We'll just run through number 2 as well, just to get you loosened up and thinking back in terms of exponents. What is the common base here that I can force 3? So 3 to the what is 9? 2. So I'm going to do 2 times a plus 2. And 3 to the what? 3. So this is going to be 3 times 4a minus 2. Is that coming back to you a little bit? So this would be 2a plus 4 equals 12a minus 6. And then I would solve from there, subtract the 2a, and add the 6. So 10 equals 10a, which means a must be 1, right? But what happens when we get ourselves in a situation where we can't just manipulate the bases? In other words, I end up with something like number 3 on here, where I am 2 to the x equals 61. There's absolutely no way that I can rewrite 61 as a base of 2. Do you agree? Because 2 to the 6th is 64. 2 to the 5th is 32. There's nothing in between. There's no way that I can do that. Does that make sense to you? Do you have any idea? Well, you probably have already read. Here's what we're going to do. Your steps are on there. First thing we're going to do is make sure we get that exponential piece alone. That's the isolate part, right? So we want the exponential piece just by itself on one side. And in this case, it is isolated, right? Your steps here say take the log of both sides. I'm going to say instead of taking the log of both sides, I'm going to tell you to change the form. What do I mean by change the form? What's that mean? What form is it in now? Right now it's in, somebody said it, exponential form, that's right. And what's the other form I can go to? Log form. So rewrite that in log form and let's see what it looks like. Log, what's the base? Of equals, well, look at there. It's solved for x now. You can put this on your calculator. Now remember your calculator's a base what? 10, so I have to do a change of base. So how do I put this in the calculator? Log 61 divided by log 2. Somebody do it and tell me what you get. 5.9. The log, the only difference is once we get it isolated, we're changing the form back into logarithmic form instead of exponential form. Let's look at number 4. Well, it depends. We might have to do some more. Yeah, some more to it. Tell me when you got it. But when you type it, you have to type it this way. Y'all got that? Yes, Miss Bedelia. Thank you guys. Okay, is the exponential piece isolated? It is. And what I mean by that is the base with the exponent. Okay? It doesn't matter that there's multiple things in the exponents. I just want to isolate that portion. So now that it's isolated, I want to change the form. So log, what's the base? Of what? 92. What does it equal? I'm still not solved for m, but that's okay because I can. I'm going to put this in my calculator first and find out what does that exactly equal. What do you get? There you go. I'm going to go two more. I'm going to take it out two places. Equals m minus 7. Can you solve that for m now? How? What are you going to do? Add. I hope you find this is not that bad. Not exactly the worst. I'm going to do a couple where the exponential is not isolated quite yet, but it doesn't get, I mean, it's not a whole lot harder than that. Let's do number 5. And if you especially understood logarithmic equations, then exponentials are easy. Is the exponential piece isolated? No. I need to get rid of what? The 4. How do you get rid of the 4? Divide it on both sides. That's exactly right. So I've got 7 to the n equals 148 divided by 4 is 37. Now what do I do? Yep, log it. Change the form. Log base of, that's right, equals n. Put that on your calculator. I'm not going to bore y'all with examples if you're understanding. I want to do a couple more that are a little more complicated. As far as getting the hardest thing is getting the exponential piece by itself. So let's look at let's look at 10. Negative 2 times 5 to the p plus 7 equals negative 63. Remember, I'm trying to get the base with the exponent completely isolated. So move everything away from it. But you got to remember the order that we solve in. So what should I do first? That's right. Subtract that 7, right? Move that 7 because remember when I'm solving, I'm going STADMAP instead of PEMDAS. So I'm going to subtract the 7. So I have negative 2. Now what can I do? Divide by negative 2. Now what? Log. That's exactly right. What's the base of, put that in your calculator. Two-point what? Easy. One more and I'll be done and let you. Then whenever I'm done, if you want to finish up on your project or you want to do the classwork and homework that'll be due tomorrow, you'll have plenty to do, but I don't want you up all night. Yeah, I'm going to do one more example that's got maybe like 14 maybe. But yeah, that's all there is to exponential equations. We probably could have done this when we did logarithmic equations, but I didn't want to throw, I'm trying not to throw too much on you at one time. But I'm trying to wrap this unit up too so we can be done and review. What first? Subtract 10. So I have 3 times 8. What now? So I'm left, now you have successfully You have successfully isolated the exponential piece. So I'm ready to do the log. So log base 8 of what? Get your value for that log first, and then solve for the n. What is it? 1.60. These are just on the calculator, y'all. And now it's a two-step equation. So this is log 28 divided by log 8. Yep. Yep. Subtract 3. And divide by 7. Or negative 7. What am I doing? Brain farting. And then divided there, so what do you get? 0.2? What do you think? Do you need me to do some more? Are you okay? Have any questions? Annie, are you okay? Okay, any questions at all? Y'all good? All right, I'm gonna trust you.